So thank you all for being here. Today I'm going to talk about including sign languages in natural language processing. The background and motivation in this talk are all from a paper that we're just publishing in ACL this year with the same title of the talk, but I'll get into more current stuff as well. I always like to start when I talk about sign languages by the fact that I guess everybody finds very surprising that there is no single sign language. There are many. There are around 200, at least as far as ethnologue registers. They are usually geographically based. So just on screen, you can see like there's American, there's Brazilian, there's Australian. I'm here right now in Switzerland, in Zurich, which is the German-speaking part of Switzerland. So there's Swiss German here. Each sign language can also have different dialects. So Swiss German has 5 dialects, as far as I know, because of 5 large deaf schools here in the German-speaking part in different cities. And it is important to note that these languages are the primary means of communication for many deaf and hard of hearing individuals. So it is not that it is just some kind of system, but it is the primary mean of communication. It is the language one uses. Sign languages are also fully fledged languages. So like we have spoken languages, maybe like English or German, sign languages have all of the linguistic properties of a language, and one can communicate basically everything that can be communicated with a spoken language. They're not manual versions of spoken languages, meaning that there is English, the spoken language English, and American Sign Language is not specifically a manual version with the same syntax and same lexicon, but a language of its own. And in sign languages, they make use of the face, the hands, the body of the signer, and the space around the signer. Sign languages, they consist of phonological, morphological, syntactic, and semantic levels of structure that fulfill the same social, cognitive, and communicative purpose of any other natural language. So we're used to spoken languages, and when I say phonology in spoken language, it comes from phoneme, right? It's the sound. It's the sound that I'm speaking. But sign languages are a bit more fine-grained than that. So there are many types of movements or positions that the body can be in or can do. Thus, phonemes in sign language are basically minor changes or minor sets in the position and movement of the body. We can see this when we try to compare minimal pairs of signs. So if in English I would compare rat and mat, where the difference is the R and the M, the ra and ma in the beginning there. So in sign language, I can compare, this is an American Sign Language, this is the sign for different, and this is the sign for language. I'm just changing my shape of my hand, but the movement and everything else stayed the same. This is the sign for dating, and this is the sign for dessert. The shape of the hand stays the same, but the orientation differs. Sign languages also have simultaneity. Which means that one can use multiple visual cues to convey different information simultaneously. One can use, let's say, for example, both hands to express one thing and then something on the face to express an adverb or a question mark. Or one can sign one thing with one hand and another thing with another and try to relate between them. There is also referencing, which is, I guess, one of my favorite features in sign languages. Referencing is the ability to point into locations of people's objects or just invent a space for non-existing reference. And then with that, one can refer to these. Lastly, I want to maybe introduce fingerspelling, which is manual gestures corresponding with written orthography. This is borrowed language. So in American Sign Language, it's not the predominant language of the United States. So to have concepts where they do not have signs for, they need to borrow from English, or names they don't have sign for, they need to borrow from English. So there are hand shapes that represent the alphabet, and one can sign the alphabet. Fingerspelling can also be what's called lexicalized fingerspelling, which is when a fingerspelled word kind of morphs into a sign. Now I want to take a look at the representation of sign languages. Most naturally, when one thinks sign language, one thinks of a video or visual. So here we see someone and she's signing your name, what, in American Sign Language. But this is not the only way to represent sign language in a video. So we have the video, we looked at it just a second ago, and I flattened it so one can see the frames. We can also do what's called pose estimation. So we can take the video and extract joint positions in the human body to understand where everything is. This is a representation that closely can represent the sign language, as it does have the locations of everything in the body. It does lack the ability to now sign. For example, she can sign something is the color of my shirt, same color of my shirt, but we can't see the shirt in the pose estimation. Or these pose estimations don't have tongue position, for example. So maybe future ones will, but right now they don't. And this is indeed necessary for some signs. And pose estimation does have other limitations, like the fact that they are not very accurate all the time or most of the time. And especially when both hands interact with each other, or when the hands interact with the face. So either the hand or the face will just not have good estimations. And then there are other more interesting to me representations of sign languages. So there are written forms of sign language. So sign writing and Hamnosis here are two universal written writing systems of sign language. So here we have basically 3 tokens for the 3 signs that she was signing. In each writing system, it's written differently. I think that the first one, sign writing, is a bit more easy to understand because it is laid out on like an image, a 2D grid, while Hamnosis is written linearly, one symbol at a time. And we also have, in the end here, gloss. Gloss is just a way to give an ID for a sign. The ID could be 1, 2, and 3, but in this case, to make it easier for dictionary-like understanding of the signing, the first ID is your, the second is name, and the third is what. So whenever there is this sign, then it's your. And you can see that this is not English. Your name what is not what is your name. For these representations, there exist some sign language resources. The resources that currently exist usually mostly apply for the translation between sign and spoken language. So we have dictionaries. I'm sure all of you are familiar with the spoken language dictionaries, but here we have dictionaries between sign and spoken language, where we usually have one-to-one mapping between a spoken language word and a sign language video, or maybe another representation like sign writing, for example. There are isolated sign resources. These have smaller vocabulary, but more videos per spoken word, so more examples. There are finger spelling resources, which have the most limited vocabulary. The vocabulary is usually the alphabet and maybe the numbers 0 to 9, so maybe 35 characters. But there they spell words, complete words. And there are continuous sign resources, which are resources for sentence-to-sentence translation, sentence in spoken language to a sentence in sign language. These are similar to the resources that we know from machine translation, where we actually have a sentence in one language and a sentence in another. It's just that here, the other language sentence is usually a video. And I should say that all of those are very small, usually. So we don't have millions of sentence pairs. A continuous sign data set would have in the tens of thousands, maybe. One more thing to note is that most resources are either not available for use or available under heavy restrictions and licensing terms. This is so different than normal NLP work, where basically everything's open and you can download whatever, because text is not usually personally identifiable and doesn't come with legal implication about person's likeness. So sign language data is especially challenging to anonymize because we want to see the face and other physical features. And that really limits the open distribution of data sets, which is very unfortunate. I should say that I have started a library called Sign Language Datasets, where it is a library that allows to basically load datasets in sign language in TensorFlow datasets. And I hope that it grows and people contribute, and then we have more data to work with. Finally, in this section, the perceived, I think, goal of all of these existing sign language works currently in the literature is to get to some kind of translation system. So we have a spoken and sign language pair, and we want to translate between them in both directions. So we want to write hello and get some kind of video. In this case, it's an avatar of some signing hello in American Sign Language. And we also want to be able to maybe feed in a video, perhaps from the webcam, and then get an English translation of that. We're not there yet, not at all, but this is the perceived goal, which makes it quite interesting to note that most of the works on translation of sign languages don't actually come from the NLP community. So the NLP community are the experts of translation, but most of the works are by computer vision and signal processing and not by the ACL community. Here we can see like the orange line is the ACL community. And you can see that there are basically bi-yearly bumps for a workshop that happens every 2 years. But other than that, most works happen outside of NLP. A bit bizarre to me. It is bizarre to me, and I'll give an analogy in spoken language. So we get a video in sign language and we want to translate it to text in a different spoken language. It is like I would get a WAV file or a spectrogram of spoken English, and I would like to get Hebrew text as output. But we don't do that in NLP. What we usually would do, and if this was the scenario, then we would first perhaps do English transcription using some kind of phonetic representation, or maybe even just English transcription if we know how English looks like and we have a system. And then we have a written form of the input and a written form of the output. And here NLP excels. We know how to work with these discrete representations, and we know how to do this translation. But we rarely work on the actual audio waves. It is absurd, it's bizarre. So I think that instead of working with videos, we should adopt and use these phonographic writing systems as an intermediate representation. So we have talked about sign writing and hamnosis, two options. Personally, I like sign writing a bit more because it's more visual and easier for me to understand. And it actually also comes with some linguistic backing. So there is the question of why write sign languages at all? So the linguists say that it is to preserve ideas over time. Think about it. If I have an idea, I don't go tape record and say it and then listen back. I just write it down in English. We can also send ideas over distance. This is less, I guess, feels like less important in the era where we can send videos to each other in real time, but still one can send ideas over distance with a writing system. It is a new form of expression, and it also helps in language preservation. That's what the linguists say, and that's all well and good. But I say that it's really good. I don't really care about it for my purposes. I want to write sign languages to make current NLP methods applicable to sign languages. So current NLP methods work on spoken languages. And I think that given a written notation system for sign, they could be extended to work on sign language as well. It will help to facilitate anonymous data sharing. If we have a video of a person, it's a bit harder to share. But if we have a writing of what they signed, then only the content here matters. And if they don't have, I guess, some copyright of the content, then the content can be shared. You probably cannot see who signed this sentence here or try to even understand features about this person because it is just content. And also to separate between computer vision and NLP. So in spoken languages, we have the signal and speech processing community that does the speech to text transcription. And then we, the NLP community, take that transcription and do whatever with that, whether it's translation or any other NLP pipeline task, right? We do, I don't know, pause tagging, dependency parsing, a full range of tasks on that written form. We don't do it on the audio signal. We give that to a different community to deal with. And I think this should be the case here. The computer vision community should deal with the transcription, and the NLP community should deal with the language aspects. I want to give a look, I guess, at sign writing as one option for these transcriptions. On screen, we can see kind of a video of this sign writing that happens frame by frame. This is called continuous sign writing, where for each frame of a video, we write all the things that are relevant to that frame. We can see the face of the signer and how it moves, the hand shapes of the signer and the hands, how they move in space, and how different things happen and touch. I don't really like this continuous frame by frame idea because it just happens frame by frame and not consolidated into actual tokens. So we can also do tokenization. We can take this video and write it with 8 different tokens right here in sign writing. where each token represents this canonical way of the sign that this person signed. And from this tokenized version, one can do the next step of NLP. But always there is a but with this sign language. Can we actually do tokenization? I came to here, I said, okay, we can do NLP, we can do transcription, tokenization. No, why not? So not always. Sign languages do contain simultaneity. So we have different things that can happen at the same time, and they're not discrete to one another. Things can exist on a phrase level. So in this example here on the right, basically there are phrases, it's written from top to bottom, where you see this gray line that represents that a feature, a phoneme, occurs during multiple tokens. So here we have 4 tokens, and all of them happen with this facial expression. So the tokenization is not quite clear, and there can also be leakage between consecutive signs. This has direct implications on the pipeline. So without tokenization, maybe we could do some kind of form of translation, but still there exists the problem of other tasks like part of speech tagging. How do we do part of speech tagging to sign language? I don't know, that's an open question. How do we do dependency parsing, semantic parsing, named entity recognition? It's not easy when we don't have tokens to just point at and say, okay, this token or this span of tokens is this. If we don't have these tokens, then how exactly are we to do these tasks? I'm not sure. And now I want to dive into my more recent work on how I am doing this. So I'm currently working on sign language transcription. I'll start by taking a look at the construction of a sign. So here on the right, you can see that there is a picture. This is written in sign writing a sign. There are many different phonemes here, and I'm writing them all down. So on the face, for example, the eyebrows are straight down, meaning they are furrowed. The mouth is open and wrinkled. It's like a kiss face, but open. The movement, that's the arrow on the top, is called floor plane, single, straight, small. It is moving the face forward. We also have a hand here. The shape of the hand is hand, fist, index bent, which is this shape. It's like holding a gun. The handedness is right. So this is the right hand and not the left hand. It is parallel to the wall plane rather to the floor plane. It is facing to the side. So the side, not the front, not the back, just the side. It is rotated 1/8 or 45 degrees clockwise. It has a contact point with the chin, and it has these 2 dots, which represent movement. The movement is called squeeze large multiple, which is, if this is a trigger, then we need to squeeze the trigger. And this sign is the sign for who in American Sign Language, the question, WHO, who. You can see that it is a very nice and compact image to represent all of this information. How can we now make a transcription system? My idea is that we just need to take each of these different phonemes as a task by itself and go at each task alone. It might be better to do everything end to end and have everything at once, but for that we need data, which we don't currently really have. And so if we do each task by itself, it might not be as accurate, but it will give us a start. So to start, I am relying on a 3D pose estimation system. So this is Google's MediaPipe Holistic Pose Estimation. It's a real-time pose estimation system, and it can work on the web and in Python. So we start with this, and from it, we can understand the locations of things. So we can understand where the hands are, where this shoulder line is, where the face is. I'm also drawing the arms for what's called full body sign writing, but everything is adjustable. Something additional here is that we can understand the other features of the hands. So let's look at this, for example. So what this does so far is it can understand the location of the face and the hands. It can understand the handedness, because the handedness is just right or left hand, and we have this from pose estimation. It can understand what is the plane to which the hand is facing, whether it's the wall plane or the floor plane. And we can also do rotation directly from this pose estimate, just understanding what's the rotation of it on screen. So we have a bone, we take the slope of it. Next, there is hand shape. So there are 261 different hand shapes in sign writing, which is many. Not every sign language uses 261 hand shapes. And sign writing actually has a manual with these 261 hand shapes, where each hand shape is shown 6 times. See the sign writing symbol for it, and an image. And because we have an image, we can do some pose estimation. and then train some system to understand what is the current hand shape. We have them in different orientations, but this is not quite enough, where we have one example for hand and orientation. So I'm doing some tricks of normalizing the way the hand is in 3D space, and then it's a bit easier. But you can see that pose estimation is not perfect as well. So the first, second, third ones, they look decent. The fourth one, maybe not this finger, but the fifth one here, this one in the middle in the bottom, it predicts that the index finger is the thumb. And so training on this data does indeed have a lot of noise and can lead to mistakes, which is unfortunate. But what I'm hoping for and what I'm basing my work on is that pose estimation systems are improving rapidly. Month by month, we can see improvements in these systems. So what I'm hoping for is that as these systems improve, my transcription system also improves. So this is a video I recorded of myself doing the digits from 1 to 9 in American Sign Language. You can see that here, this hand is my left hand, and I'm pointing that way. The hand is to the side, and I'm making the shapes for the digits 1 to 9. So it's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this does the hand shape. Cool. So we're getting some progress. Next, I wanted to look at the face. So for the face, there are many, many, many different phonemes and features. The eyebrows can be in like 12 different positions. The eyes can be in many. The mouth can be in 20 plus. There is a way to do teeth, tongue, eye gaze. There is even a sign writing for eyelashes. There are way many, and there is no data. There is no data where I can look at faces of people and have this annotated. So to create data, I found this really nice paper. It's called Style Clip, Text-Driven Manipulation of Style GAN Imagery, which allows to modify images of faces or other things using text prompts. So for example, in this case, I have this image here on the left, that's the source image. And if I have this prompt that says to furrow the eyebrows, to make the eyebrows down, then in this image, the eyebrows are down, and this image, the eyebrows are up. And I can replicate this now on thousands of images of different people and get a very diverse data set, different races, different genders, different ages with all these features. So in this case, for example, is for the eyebrows. This is 3 of the features that can exist, but can exist many more. Eyes, for example, so the left one is the source image, and then the next one is squinted. The next one is called bug eyes, so eyes wide open. The last one is eyes tightly squeezed. We also have mouth. So this is the source image. I do not prescribe any feature, any label to it, but then we can do an open smile, an open frown, a closed frown, a closed smile, etc., etc., etc. And we have many, many of those. This part is still work in progress. So I colored it as lighter yellow because I have created a data set with many of these features. And I'm now working on training a model and getting this to really work. So fingers crossed it does. Next things that exist here are movement and context. Let's talk about how one can approach these. So for movement, I think that I can trace body parts through frames. We have this line moving in time and space, and then we can characterize it as a certain type of movement. I will need to collect some data for it, as there are many, many, many types of movement. But I think this is doable this way. Contact is a bit of a harder problem because it's unclear how to do it using pose estimation. If we have pose estimation, we have the location of joints in the body. And then if maybe my hand is touching my chest, there is no, I guess, intersection of the joints. How do we define that a centimeter or 2 is touching and 2.5 centimeters is a hand floating? So how do we make this distinction? Unclear how to do it for video. It's very unclear how to do it for pose estimation. There is also then the next problem, which is given that now we have a video transcription system, we have the sign writing for every frame, we need to know how to segment this video into different pieces representing different signs. So we have a video saying your name is what, and we want to segment the frames for your, the frames for name, and the frames for what differently. So we have these segments, and then we also want to convert them to a single token. So if we look here again, we have a single token here on the right, but it's representing this kind of sign. And this sign is not a single frame. It has some movement, it has the changing of the eyebrows, it requires some frames, and it also requires to condense these frames into a nice representation like this. That's all I have for the transcription. I want to conclude by saying that sign languages should be included in NLP. I think this is a message that people can actually relate to and understand why this is the case. Sign languages are languages. And personally, I think that the way to do it is by transcribing videos to a discrete written notation system. So if we take on a written notation system and do a transcription first before we do anything else like translation or any task from the NLP pipeline, I think that we will be better for it. If you want to follow this work, I also post videos about what I'm doing on YouTube. This work lends itself to video because we have sign language and we have a system. There is also a playground that is open source where you can play with these sign language transcription. And if you want to contribute any code, feel free. I always love to see what people do. I also have a Twitter if you want to follow that. And other than that, thank you so much for attending the talk today. And I will be taking questions if you have any.